Hi, welcome to question 9 of the 2023 paper 2 for the Leaving Cert Ordinary Level Maths. As always, if you want to copy the notes I'm working on, just send me an email to shanetroy@gmail.com. Like and subscribe to get access to more playlists. So we have here now part A has 4 parts to it, and for some reason part 1 and 3 are graded together, okay, and they're worth 10 marks. So just look at the marking scheme there. If you get one of the answers right, you'll get the high partial or work of merit in both parts 1 and 3, and together they're worth 10 marks. So let's read through. Now, as always, some of these questions in section B can be long-winded, so take your time, read it multiple times if needed. The times that I only read it once or twice are the times that I mess up, okay, because sometimes one word can have meaning, okay. A group of students decided to investigate the average amount of time that students in Ireland spend reading each day. Now, it's worth noting that in maths, the average refers to 3 things: the mean, the mode, and the median. Now, sometimes in the real world, the average is kind of what people assume you're talking about the mean, which is add up all the data and divide by the number of data points. So we'll see what they mean here. One Monday morning, they asked the first 200 students, okay, now the first 200 students matters, who came into their school, how long, on average, they spent or spend reading each day. The results are shown in the table below. So I'm not going to read through the table, it's self-explanatory. But this is a grouped frequency table. Now, group frequency tables lose something in their translation. Now, I don't think that's being asked in this question, but for example, these 16 students who spend between 0 and 30 minutes reading, do they all spend 0? Do they all spend 30? Or is it a mix of stuff in between? Or is it the average, which would be like 15 minutes? Okay, like the mean of that would be 15 minutes, or we sometimes call that the mid-interval value. Now, I don't know. So without seeing the raw data, I can't tell much more from this than that. Now, we do it because this is probably all spread out. If you made a table of one student read for 1 minute, two students read for 2 minutes, you'd have a massive table. Okay, it'd be just unreadable. And the reason we use tables to represent data is there's too much for our brains to handle. We can use a graph or use a table, but they're just trying to represent large amounts of data. Now, this isn't large. I mean, it's 200, so it's not insignificant, but it's not like 2 million, okay, or 200,000 or whatever. Now, part 1 says work out the maximum number of students in this sample who, on average, could have read for more than 100 minutes per day. So the maximum number of students who could have read for more than 100. Now, anybody below here, okay, read for less than 100. Like, even if everybody here in the 62 students read for 90 minutes, that's still less than 100 minutes. Now, in the next band, the 59, now they could have all read 90, okay, but they could have all read 120, which is over 100 minutes. So I have to include all 59, okay, plus, now in the 120 to 150 band, well, they're definitely reading 100 minutes, plus the 10 at the end. Now add all that up, and I got an answer of 87 students. Okay, that's it. That's all. Now, so if we got that correct, we got the 6 marks out of 10. I'm going to flick on to part 3, okay, because they're marked together, and I'll come back at part 2. Explain why the method of choosing the students for this survey could limit the validity of the students. Now, they said that it was the first 200 students, okay. Now, I'm going to make some stereotypes here, and they may or may not be true, and you may or may not agree with them, but they're possible answers. Now, if you have a school of, like, let's say 400 students, and the first 200 to arrive may have came by bus. Now, it depends on when the buses for your school come, but they may all come late, like last minute. But sometimes you get a bus does 2 runs, and they'll do the more rural run first, and they may all be like people who live outside town, and they'll have a certain, I don't know, certain differences. Is it representative of all the students? No, because it may only be those from farming backgrounds or more rural backgrounds. Now, you could say, with the first 200 students coming, maybe they're, now, I'm going to say more motivated, okay, and that maybe more motivated people are more likely to read. Now, I'm making a fair few assumptions there that may not be valid. Okay. Now, you could also argue, and I'm just throwing this out there, maybe the first 200 students want to get out of the house at home. Not all of the first 200, but and they are for whatever reasons, and that may affect their reading ability. So maybe now again, you could go down the road of gender. Maybe one gender wants to get there quicker than the other. Now, I'm not sure if that's true or not, to be honest, and from my experience, probably isn't. But it's still a possibility. Because of the sampling method used, you can't say that it is valid. Okay. If you had chosen randomly 200 students from the entire student body and made contact with them by going around classes, then would be more representative. Um, so yeah, there's any number of answers there. It's the first 200 students. It's perfectly fine having 200 students. Okay, as long as you didn't just pick 200 boys or 200 girls or 200 tall people or 200 short people. If they're randomly selected, or even if there's criteria for selection, as long as those criteria are fair, the sample selection process will be more fair. And this is always a problem with a study you have to be watching out for. Like, what was the sample size? Like, if you asked 2 students and said, oh, everybody in this school reads 50 minutes a day based on asking 2 people, that would be patently like crazy. Okay. If you selected the sample based on sexism, like I only talk to boys, therefore I'll only ask the boys. That's not representative. Now, unless it's a boys' school, in which case, fair enough, it is representative. So like there's any number of other situations like that in a study or a survey could be limiting the survey. Now that could be intentional, and the person's trying to get a predetermined response, and they're going to get it, irrespective, that's fraud, but irrespective of actually being fraudulent and changing the results. They could be doing everything properly to have a veneer of respectability, but trying to get a preconceived outcome. And there's any number of examples of that across TikTok, Facebook, whatever social media. That if you are armed with the tools, critical thinking tools, you might be able to see, or you have a better chance of seeing through the haze or the BS, and then making better decisions based on the information and the overload of information, in my personal opinion, that's around us. Okay, so I'll stop ranting. Now, A part 2 says estimate the median time. Now, the median is the middle value when everything's organized by increasing size. This is organized by increasing size. Okay, so the median value would be the middle value. So there's 200 students, so the middle value is 100. Now, where does the 100th student lie in this? Well, there's 65 here and 35. So that's what, 46? Yeah, 40. No, 4. It's too early. 51. So it's 51 students up as far as here. Now, if you add on 62 in maths, 113, stand to be corrected, would be up here. So the 100th student is somewhere in here. So that's the answer. Okay, the 100th student must lie in the 60 to 90 minutes reading per day. Now, how many minutes does that 100th student read? I can't tell you without seeing the raw data. Okay, but it's between 60 and 90. I can tell you that. Now, actually, part 2 was worth 5 marks. Okay, so part 4 is worth 15 marks. Now they're being kind of open-minded here, or not open-minded, pretty loose here. Sometimes they'll say in the past, draw a pie chart, draw a bar chart, draw a histogram. Okay. Here they're saying draw any graph or chart to represent the data in the table. Show clearly any relevant calculations. Label your graph or chart clearly. Now you could do a histogram, okay, but all of these divisions are equal. So a bar chart might be more appropriate. Okay, so if I drew a quick bar chart, now straight lines are not my thing. That's 0, so that might be 30. So that's the 0 to 30 band. This is the 30 to 60, etc. Okay, now here my maximum number is 62. So I might go up in divisions of 10, 20, 30, 40, 50, 60, 70. Now again, it should be a straight line. Use a ruler. And 16, if that's 10, that might be 16. Then 35 would be, now 10, 20, 35 might be here. And you continue using a ruler. Okay. Now, bar chart's fine. I could use a pie chart. Now, a pie chart is always out of 360 degrees. Now, we don't know what degree it is, but we do know the fraction in the first category, 0 to 30. That's 16 over 200 students multiplied by 360. So this is the fraction of the total students. So 16 200s would be what? 2 800s, okay, which I'm sure you can simplify down into 425ths, no, 225ths. I think I'm right there. I just should use my calculator. Or just use the calculator, multiply the fraction 16 over 200 times 360, and I'll get a degree. Now, I'm going to just say it's, actually, I do know the answer. Oh, they're not written here. No, they don't have it. Okay, I'll come back to that in a second. I'm going to say just 25 degrees. Okay, now I'm just making that up. And do the same thing again and again and again. And then I can use my protractor, okay, which you have in your math set, which you brought to the exam, okay, and your calculator and ruler for things like this, and just measure out 25 and then go again for whatever the next band is. Now, I did a bar chart here, although I just use Excel, so I don't like when the bars are spread apart, although that's not necessarily that bad. There's a histogram drawn here, which is kind of like what I drew, but a histogram really is only different than a bar chart when you have different size intervals, and then you have to follow a methodology. So really, a histogram is a type of bar chart. And then the pie chart might be a little bit harder to do, but I think most students generally get the pie chart. And in previous years, when they've asked the pie chart, sometimes up to 25 marks, I think, if I recall, from like 6 or 7 years ago. It's a chunk of marks, and 15 marks here is a fairly decent chunk. Now, in the marking scheme, they're saying there that if you identify axes or sectors, you'll get the low partial. The high partial is 4 intervals drawn or 4 slices of the pie drawn, and then without labels, you'll apply a penalty. So I would have argued down here, they have a legend, but I would have put in the percentages in here on the pie chart, or as much information as you can. Even if it's overloaded, you can't be saying you didn't label if you overlabeled. Right, that's part 4. So I suppose you should know how to draw a bar chart. You should know how to draw a pie chart, because they could come up and they're a significant chunk of marks if and when they do for little work. It's just a lot of grunt work, but it's not like overly complicated in the scheme of things, especially comparison to some algebra questions. Now, part B says, a random sample of 500 students in Cork took a statistics test. 61 of these were given a rating of excellent. Work out the percentage of students in this sample who were given a rating. Well, if I know the fraction of the students, so there's 500 students in total, that's the total denominator or bottom part of the fraction. We're currently talking about 61. That's the answer. But they do say they want a percentage. Now, percentage is always out of 100. So we multiply by 100 to get our answer of 12.2%. So 12.2% of the students in that random sample achieved an excellent result. That's all. So 10 marks, it's a fairly handy amount of marks. Okay, the next one then is B part 2. Now, B part 2 is leading into the hypothesis testing question, which is, from my experience of marking the Leaving Cert, is one of the less well answered questions, but there is a pattern to it. And this first part will generally be asked, or at least it's always been asked in my experience. And the probability here, the margin of error, so margin of error, the formula is 1 over the square root of n. Now, if you want to see, the margin of error, for example, the smaller the n value, the bigger the margin of error, okay? So actually, I'm going to have to multiply that by 100 because we want a percent. Okay, that would be the formula we need here. Now, we were told the sample size was 500, so 1 over root 500 times 100. you can use the calculator and program that in, okay? And I got an answer of, no, I simplified it down by hand for some reason. Maybe that was the answer I gave my calculator. I turned it to a decimal and then multiplied by 100 to get a percentage, and I got 4.47%. But the question has an extra stipulation to round to one decimal place. So the 7 here is what matters. It's greater than 5, so it rounds up the number before, and I got 4.5%, which in a sample is a fairly large margin of error. Okay, you could be 4.5% overestimating or underestimating based on the randomness of the sample. The larger this number, the more representative. So usually surveys, or polls are of 1,000 people. So it'd be 1 over root 1,000. Anything below that is considered to not be as accepted. Like if you asked one person, okay, 1 over root 1, okay, would times 100 would be 100% margin of error. You could be right or wrong because only one person asked. 2 people is a little bit lower, 4, 10, 15. The bigger, if you asked 1,000,000 people, the margin of error is very low, okay, because of that. So this formula is not given in the maths tables. I stand to be corrected if I'm wrong on that. I've looked numerous times and I don't know why. But it's just when you have to memorize. It's a 5 marker for a simple formula, and there's not for many formulas to learn off, but this is one, okay, because this will be asked. At least I'm fairly sure it'll be asked. It's been asked for the last 6, 7 years. And it is a super important thing in critical thinking and science. So that could be what's leading into it. Now, here's where the harder question comes in, and this is the one that's very poorly answered. But in the marking scheme, okay, you're getting a work of merit for writing the answer from part B1 or B2, just writing the answer. So if you take the 4.5% and write it on the page, you have the low partial of 2 marks. Okay. Now sometimes this is given 10 marks. It's given different every year depending on how to meet the curve. Okay, but this 2 marks out of this particular question, happy days. Okay, for a lot of people, there's nothing written here. It's blank, which is great when you're marking, but not so good for the student. So let's get stuck in. So in general, 10%. Let's write down 10%. Now let's write down the 4.5% over here, just to have the attempt margin of error. Make it clear what it is. Okay, now even 4.5% when it's written on its own should get it based on my reading of the marking scheme. And then use your answers to part B1 and B2 to test the claim. So part B1 was 12.2%. So I'm doubling up. And I'm just looking at the marking scheme. To test the claim that the percentage of students in Cork who would get a rating of excellent is different to the population percentage at the 5% level of significance. Show relevant calculations, state your conclusion, and give a reason for your conclusion. I'm going to go to the answer, okay? So we were told in part B1 that 12.2% of students got a rating of excellent. That's what we calculated. Now the margin of error is saying that based on the number of students sampled, that could be, it could be more up by 4.5% or down by 4.5%. Now sometimes that's written like with this p hat thing. So you could write it maybe like 12.2 take away 4.5 is less than or equal to p hat is less than or equal to 12.2 plus 4.5. Excuse my bad writing. That gives you a range of 7.7 as up as far as 16.7. That's it. That's the calculation. Now, what does that mean? Okay, does 10%, okay, actually I should have said 10%, 10% falls within the 5% level of significance. Okay, so you could say, or say, just the marking scheme says there's no difference between Cork and population proportions. Okay, but either way, it's the same thing. Now, the reason for the conclusion is, I suppose I'm restating the reason. 10% lies between 7.7 and 16.7. You're just being direct. And this would be a piece of advice that I would always give. Assume the grader is an idiot. Okay. Now, if that's me, that's fair enough. Okay. And they're not idiots, but like make it obvious to them. They can't interpret what you think you mean. Say it, draw it, be explicit. Okay. Don't leave it up to interpretation. That's a skill in life. And sometimes we kind of assume, oh, of course they know what I mean. And you'll be surprised. Like if you have 10 people in front of you, one person's going to take the wrong end of the stick. The more explicit you are, the more chances you have of getting explained to them. Now, there's always one person, so maybe not. But sometimes you can go overboard and over explain, and the work is lost. So, which is why I try to, and I don't always do it, put my answer in a box, make it logical progression of thought. Start on the left, work down, move over, work down. Make it presentable. You're trying to show somebody your level of ability in maths or English or whatever subject you're doing, okay, or in your job later on in life. And if you can do that well and communicate what you're trying to get across well, you'll do well. And that because that's a skill. Okay, and it's a skill we don't always have. We're definitely not born with, and one that I've been working on for years, and slowly but surely have gotten slightly better. Hopefully someday I'll be perfection. Now that's the end of question 9. Okay, and if you want to copy these notes I'm working off, just send me an email to shanetroy@gmail.com. Like and subscribe to get access to more playlists. See you on question 10.